A sample of 100 tires is taken from a lot. The mean life of tires selected is the sample is found to be 40,000 kilometers with a standard deviation of 30 to 100 kilometers. It is reasonable to suppose the mean life of tires is a lot at 41,000 kilometers and 5% level of significance. Also established 95% confidence limits within which the mean life of tires is the lot expected to lie. So what we have given in the questions, first of all we have given the 40,000 as a mean and the standard deviation is 32 kilometer. So we are given that the mu 0 is equal to 41,000 kilometers and standard deviation is equal to 32 kilometers, 3200 kilometers, and the sample size is 100. And now the sample mean x bar is equal to 40,000 kilometers. So this is the four values are given now, and in this example the population parameter being tested is population mean, average life of a tire, and we want to test the company's claim that average life of a tire is 41,000 kilometers. So our claim is mu is equal to 41,000. So suppose that in my samples my mean is 40,000 kilometers, but our claim is 41,000 kilometers. So mu is equal to 40,000. We are claiming that our tire is 41,000 kilometers can run, and its complement is mu is not equal to 41,000. And then so H null hypothesis is mu equal to mu 0 is equal to 41,000 kilometers, and if not is equal to 41,000 kilometers, so this is called the alternative hypothesis. This is called H1. Now the alternative has is two-tailed, so that the test is two-tailed means that the value is less than, it can be less than 41,000 and it can be greater than the 41,000. So alternative hypothesis two-tailed, so the test is two-tailed test. So we want the hypothesis regarding mean when population is known and sample size n is equal to 100 is large. So we will go for Z test. Thus, for testing the null hypothesis, the test statistic is given by Z is equal to x bar minus mu 0 upon sigma upon root n, and the value is given is here. X bar is equal to 40,000 and mu 0 is equal to 41,000 and sigma is equal to 32. Then after the calculating value of Z, so we get the value of 3.125 minus 3.125. The critical values for two-tailed test at 5% level of significance are, this can be obtained from the Z table, and so you can easily get from the Google and also in your books. So 0.025, 5% of level of significance is 1.96. So we can say that, so we can see easily that the calculated value of test statistic, calculated value is test statistic z is equal to minus 3.125 and is less than critical value. So critical value, that means it lies in the rejection region. So we reject the null hypothesis is the claim. So we support the claim at 5% level of significance. So this is the final result of this test. So we reject the null hypothesis and we accept the alternative hypothesis because this is the very less than our value. So confidence interval here test is two-tailed, therefore we can contract two-sided, thus 95% of confidence interval. So confidence interval z x bar is minus z alpha by 2 sigma upon root n, and after the putting the values we find the values are here. So these are the two values of confidence interval in which our value will lie. Since 95% confidence interval for average life of a bulb contains the value of the parameter specified by the null hypothesis, so mu is equal to 41,000, so we reject the null hypothesis. Thus we conclude that sample does not provide us sufficient evidence against the claim. So we may assume that the company's claim that average life of tire is not true. So because the 41,000 is not get the exact value, because we get the in between the two values, which is the 39,000 and 40,000 between them. So this is the final result of this question. Thank you so much. If any confusion and any queries, you can comment on the comment box. Thank you.